Hello, community. Let's talk about OpenAI plugins and how they do the real-time data retrieval. Now, last time I showed you in GPT-4, we were implementing the 3-of-sort algorithm, and I used 2 plugins for the external interface for access to the internet. And my audience had some question about how does this work technically? Why I've chosen those plugins, and do we have to work here again with vector embedding, and what vector stores do I use? So let's start at the beginning. API, you know API. Application Programming Interface. A program that wants to communicate with some other software uses an API. And since an API endpoint is the end of a communication channel, we can use specific HTTP methods like get, post, put, or delete to communicate over this channel. If you want to go on and continue learning with me, for OpenAI, there's this specific repo, ChatGPT Retrieval plugin, that explains everything in detail, and I use this documentation for my learning. So the OpenAI Retrieval plugin, this was open sourced, is built using FastAPI. This is a web framework for building APIs with Python. And the API endpoints are specific paths in the API where certain function can be performed. And this is what we want, because we want that an endpoint might be used to retrieve or send data from or to a database. And those API endpoints have a standardization, and this is why it's so easy to click together different software systems and make them interact. Now, those endpoints can communicate with various elements. As I told you, either you have databases, endpoints can be used to create, read, update, or delete data in a specific database. I will show you an example. Or in my last video, as I told you, I used, for example, the Vox script plugin, where GPT-4, the OpenAI API endpoint, used this to communicate with Google's Search API and YouTube's Data API. The other plugin was ScholarAI, and we used here the endpoints to communicate with the archive preprint server. And then you have front-end and back-end application and services. Now, a plugin in itself is rather easy. A plugin consists of an API schema, either in JSON or in YAML, and a manifest. This is simply a JSON file that defines the metadata for the plugin. And if we are talking here about OpenAI's Retrieval plugin, it uses here some specific system, and this is the text embedding ADA 002 embeddings. Beautiful. So the OpenAI's Retrieval plugin uses semantic search. And this is why we have to use vector databases or vector stores. If we would use just a keyword search, life would be so much easier. But anyway, the semantic search ability allows here the users to obtain the most relevant document from their data sources, from their directories, the files, or emails, or whatever you have. Or if you are an enterprise, a commercial entity, if you have internal documents, you can make them available to the employees through this particular plugin and use ChatGPT. Beautiful. We have 4 really friendly API endpoints here in OpenAI that you have to know, because they are the main endpoints, and in particular one. So let's have a look at them. We have Upsert. This endpoint is simply used to add new documents to the vector database. The vector database is an element outside of GPT-4, outside of OpenAI. The documents that are fed into this new vector database are split in chunks, maybe around 200 tokens. You have a unique idea, beautiful. Or if you want to upload more complex data, we have the Upsert file endpoint. And you guessed it, it is designed to handle file uploads. Plain text, split into chunks, stored in the vector database, exactly the same. Now, the most important endpoint for us will be the query endpoint. This endpoint is used to search the vector database. It expects a list of queries, each with a query field and an optional filter and some top ranking fields. We use this filter, and I will show you in a minute what it means, to narrow down the search based on metadata or specific parameters. And then, of course, if you want here to remove documents from the vector database, we also have our fourth API endpoint, and this is the delete endpoint. So you see, our OpenAI Retrieval plugin has 4 API endpoints. Now, we have a specific OpenAPI schema, of course, that gives us detailed specification and examples. I leave you the link to the schema definition in the description of this video. Now, if you use the normal ChatGPT, you more or less only need access to the query endpoint, as this is the primary function to retrieve external documents based on natural language queries. But of course, if you have an intense and conversation, for example, with ChatGPT over several days, you want that ChatGPT remembers everything that was spoken before, so you cannot save it in ChatGPT itself. So you have to save it somewhere else. Cache would be a solution, but best thing is, of course, if you already have a vector database, you save your conversations with ChatGPT for a particular period or particular topic, also in a vector database. Beautiful. Of course, you know it is about security. So you have at first the data store, the vector database provider, they're open source and commercial. And for commercial, you have to pay up several $1,000s per year, $10,000 per year. So you get then a specific token that you are able to access it. You have an authentication token. And if you use, of course, GPT-4 or ChatGPT, you have here OpenAPI key that gives you access to the embedding using the text embedding Ada 02 model. Beautiful. You see, you have to pay OpenAI for this to get the key. You have to pay the vector database provider to get the key to have some security level. So if this is not set, your API may not work at all. Now, let's have a look at here the vector database. There are dozens and dozens, and maybe even hundreds of possible solutions. Let me focus on 2 that are open source. I like open source. I don't like to pay somebody for a service I can maybe manage myself. So OpenAI plugins support several vector database providers, each with different features, performance, and pricing. So 2 open source are here: Weaviate, an open source vector search engine built to scale seamlessly into billions of data objects, and it can be self-hosted or managed. This is the nice one. Or you go with Milvus. It's an open source cloud native vector database. It is, if you want to call it, the open source version of another paid version. And it shares many of its features. You have a lot of opportunities, and you have, of course, and this is if you're an enterprise, a cloud scalability. So either you go self-hosted or cloud, but open source are really powerful tools if you look for a vector database. Of course, if we're talking here about pure enterprise solution, professional solution, top security guidance solution, we will use here Postgres as a supported data store, and our Retrieval plugin can store and interact with Postgres database. So there is from Azure a really interesting package you should have a look at. You have here your Azure OpenAI service with the different large language model here running natively in Azure. And then you have, if you want, the vector store or the vector database. And with Azure, it is called Cognitive Search. It is completely cloud-based, scalable, and the interfaces are managed by Azure. So this is something really nice if you want to go with high security, maintainability, but of course it could be expensive. So you have to inform yourself about the prices in your region, in your nation. So cognitive search, complete retrieval, cloud service supports vector search, text search, and hybrid. Hybrid will be the next topic here. Offer some re-ranking step, improve results, everything pure cloud-based, everything proven, everything with high security. Interesting. Now, this cognitive search here uses, of course, Postgres, and here we need an extension. And we need a very easy and efficient way here to store our vectors, and there's this beautiful Postgres extension, and this is called pgvector. And if you use pgvector, you will need to set up here the Postgres database with the pgvector extension enabled. You can also run this using Docker, or you have a hosted managed solution in the cloud vendors. So if you look here for a complete solution that is really, I would say, for the high performance enterprise sector, Azure might be one of the providers you might look at. Yeah, if you want to have a feeling for this, I have here a specific YouTube video for you. This is from Microsoft Mechanics. The title of this video is Can ChatGPT Work with Your Enterprise Data? And you have here exactly this with Azure OpenAI services. So your GPT-4 maybe runs here or whatever you pay for. And then you have here your cognitive search, it is called in Azure, or vector database or vector search or whatever you want to call it. You know what it is. And there's really a seamless interface between those two. Have a look if you're interested. A very informative video by Microsoft Mechanics. pgvector, yeah, open source Postgres extension. Nice, it is open source. What is it? Simply a new data type named vector. And you're not going to believe in this new data type, you can store your embedded vector representation of your documents or of the sentence of your corporate documents. This is it. Easy as it goes. If you want to have a technical detailed Microsoft T5, Azure Database, Postgres, Retrieval plugin with Postgres on Azure, beautiful. But of course, let's look at other market player. You go here to AWS, and this is here from May 2023, building AI-powered search in Postgres using Amazon SageMaker and pgvector. Now, what a coincidence that more or less this is rolling out over our three big player, Microsoft, AWS, and Google. Diverse, yes. Have a look if you're interested. Now, as I told you, there is here this possibility for the ChatGPT Retrieval plugin that you can have this memory function where you store your data, your conversation with the GPT system, also in the vector base, and make this a new data set that you can search. So for example, if you have 30 employees and in the morning the first employee starts for a new topic, then comes in the second employee, is searching for exactly the same, and if 30 employees search for exactly the same topic, it would be a good idea to have this already in your vector database. So you do not have 30 parallel searches on GPT-4, but this is one search and one result. Great. If you want to have here a deeper look, ChatGPT Retrieval plugin with the memory, you have here all the different files that you need. I really recommend GitHub OpenAI ChatGPT Retrieval plugin examples memory. Beautiful. So, yes, I've been there. Yes, you will see that the professional vector databases, if you really have a huge one, offer you something like hybrid search. This is a very interesting option if you have, let's see, multiple topics in your vector database. Let's say you have the political news, then you have the weather news, then you have the gossip from Hollywood, and then you have mathematics. So if you do a pure cosine similarity search of all the documents in all the complete vector database without a kind of a pre-selection, without here an optimized hybrid search, you would have a cosine similarity mathematical operation with, I don't know, 100 million vectors. But you know, if you have a question in mathematics, it will be in the sector, in the segment with mathematics. So you can narrow down your search vector space to your particular topic. Hybrid search. With Azure, they call it cognitive search. I call it neural search in the literature. If you look for the BERT system or for the sentence transformer system, it is called neural search. But of course, hey, marketing has to keep up with new ideas. What is it? We enhance the data store's upsert function, remember our friendly API endpoint, with an option to use a hybrid search function or a specific indexing we call TF-IDF indexing. Now, this TF-IDF is an old method, 20 years old, I suppose, term frequency inverse document frequency. It is a statistical measure simply reflecting how important a word is in a document. So, if you have a document about the latest political news, you will not find some mathematical words in this document. So it is easy, you just check what are the most important words in this document and you can skip the rest of the document. Nice. If you're interested, term frequency, very easy, calculates the number of times a term, a word appears in a document, divided by the total number of terms. So if you're looking here, a document has 100 words, and you're looking for the specific word cat appears 5 times, you're not gonna guess what is the result. Now, the problem is that in a document you have a lot of words like is or of or that or they. So you want to get rid of this because otherwise they would be in the top position here. So we need to weigh down the frequency terms, the frequent terms like those here, and scale up the rare ones. My goodness. So this is simply here a log e function. And you're not going to believe it. If you multiply this value, you get exactly the TF-IDF score. Now, in the context of text mining that we have here, this is here a specific term that we use here in our document. We can compute the TF-IDF score for each term in each document and store these values in a matrix. And this matrix, if you read about here, TF-IDF matrix, is of course our index. So this is what is an index. This is more or less can be a TF-IDF matrix, a simply statistical function. Can be used to determine the relevance of a document. If you look for a particular search in mathematics, you do not need to look in the document about political news. This is all there is to it. So, summing up, both neural search and index search like TF-IDF have strengths and weaknesses. But if you combine them, you get more or less the best of both worlds. So, they are different. But while TF-IDF and similar techniques of indexing might be sufficient for simpler tasks or smaller data set, this neural search method are often more effective for complex queries. And if you're working with ChatGPT or GPT-4, you have complex queries in natural language formulated, and you have large diverse data set. If you're a company, you might have millions of documents. So, neural search methods are especially useful for tasks that require a deep understanding of language if you have complex queries to the system, and this is why we have vector databases. This is all there is to this story. Next time will be interesting because next time, this theory that we learned today, I will show you the flow of data between GPT-4, between this OpenAI plugin that I just discussed, and Azure Cognitive Search. We will have a flow diagram of code sequences, the flow between all those 3 elements. We will look exactly what of those 4 objects is asking for what embeddings, and what embeddings will be stored in the vector database and the vector store. Where do the embeddings come from? Where can you buy embeddings? Which embeddings you should buy? And if you're interested and you like a little bit coding, you can create your own vector embeddings of your documents for GPT-4 and the OpenAI Retrieval plugin that was the topic of today. So everything that was static in this video will become dynamic and very, very visible in our next video. I say thank you for listening, thank you for watching, and I hope to see you in my next video.